Okay, great. So I'm live. Now let's get started. This is make sure your calculators are close by. I'm gonna need you to be calculating. Everybody putting in the chat your answers. Let's quickly go through it. Welcome, IGCSE students. Today we are looking at the February-March 2026 paper, and which was written about 3 months ago because we are in July. And we want to see what they did. This is the multiple choice paper, which really is one of the first full multiple choice papers that we have done. I would have loved to start with the structured one, but it's still fine. Now, as we are solving, remember that we always need to solve them section by section. We have the 6 topics, and we are going to be seeing how they ask each topic in the exam. So we have the topic 1, which is, we can call it general physics. It used to be called general physics. Today they call it, in the syllabus, motion. In your IGCSE syllabus, it is called motion, forces, and energy. So topic number 1 in the IGCSE syllabus is called motion, forces, and energy. Topic number 2 is called thermal physics. And we are going to see how they ask it in the paper just now. Topic number 3 is called waves, including light and sound. So wave properties. Then topic number 4 is electricity and magnetism. Topic 5 is nuclear physics. And topic 6 is space physics. These are the 6 topics for IGCSE Physics that we need to know. We're going to be doing the questions together, and we'll see which topic it will be from. So let's quickly go through it and let's see. The first question says, the diagram shows a stone of irregular shape. We know what this is about, huh? Irregular shape, irregular volume. All right. Which property can be found by lowering it into a measuring cylinder half filled with water? So which topic in physics is interested in volume? We know volume for maths, it's mensuration. We have volume in physics. And volume in physics, you need to know the 2 ways to find it. One is by calculation. This is for regular shapes, which are shapes that we know. Cylinder, whatever. But then there is this one. It is not a shape that we know. It is an irregular shape. How we find volume is by putting it into water. And we'll see how the water will change its volume. So you will be having a measuring cylinder with no water, with water and no rock. Okay, measuring cylinder, you know, it has things like this. Then it has water with no rock. Then you take your rock, you put it into the measuring cylinder, and you're going to see how much the water will change volume. That will tell you the volume of the rock. So that is it. The water is going to rise. Once you put the irregular stone inside, then the volume of the water will now rise to be up here. And we'll check that volume, and we compare it to the initial. This is the initial. This is the final. So to get the volume of the rock, the irregular rock, you say final minus initial of the water, because there is no direct way of getting it. So this has to be volume. So in number 1, it is C, and we go to number 2. What does number 2 say now? We go through it quickly. Number 2 says, whatever. You know, when the question gets long, then we have to go and read the question itself. Which statement can be deduced from this experiment? Okay, we don't read long questions because we won't be able to understand them. What can you deduce? So this was topic 1, by the way. This is volume from topic 1. All right, no problem. Now we go to number 2, which was saying, what statement can be deduced from this experiment? What experiment is this? Well, we have a balloon and we have a metal block. And they say the helium balloon is taped onto the balance. Okay, no problem. A metal block is placed on the balance. Okay. The reading on the balance is 91 grams. Now, here, the statement, so the reading here is 91 grams. And they say there's a helium balloon and the metal block has 100 grams of mass. So this metal block, its mass is 100 grams. But then they say the reading on the balance is 91 grams. So we will need to know what has happened. How do we have the reading on the balance being 91 grams? What statement can be deduced from this experiment? The first one says the balloon exerts a downward force. No. The balloon cannot exert a downward force. Okay? But why? Because the reason why on here we have less is because the balloon is pulling upwards. It's pulling upwards. So it is reducing the 100 grams to make it 91 grams. Anyway, the helium has a mass of negative 9 grams. The helium has a mass of negative 9 or positive 9. Look here, students. Mass can never ever be negative. Okay? Can you all hear me? Kelly? Mass can never be negative. So this is obviously out. In part B. The helium has a mass of 9 grams. Well, we don't know the mass of helium. You can't say the mass of helium is 9 grams. Where have you seen that? Oh, sir, there's a difference of 9 grams. Yes, there is a difference of 9 grams. But you can see that the value here is actually smaller. The value here is smaller. If helium was 9 grams of mass, then we were supposed to see 109 grams here. So we don't know the mass of helium, so this is out. Here it can never be negative, so this is out. Mass can never be negative. And then here we don't know the mass of helium. So this becomes the last one. The resultant downward force is 0.89 newtons. Wow, the resultant downward force. Well, force is equal to mass times gravity, which is, what is the mass? 91 grams. This is the mass that remains. You multiply by 0.9. Is it by 0.9? What do you get? What do you get, students? Can you quickly calculate, please? What is the value of gravity that you're supposed to use? They tell you here. 9.8, sorry. Okay. So it's by 9.8, not 9.8. I was thinking 9.81 for A level, but it's just 9.8 for your age. And you say, okay, so let me explain something here because it's very important. This mass is in grams. Well, we want, this is newtons per kg, not newtons per gram. So here you had this mass being 91 grams. So you should be able to convert it to kgs. It'll be 91 over 1000, and it is now kilograms. Then it is times 9.8 newtons per kg, and now you can get. So can you do this and tell me what answer you're going to get? Real quick, please. That is why we always put units, because they then show us what we are doing wrong if we have anything we are doing wrong. So here, what is 91 divided by 100? Then times 9.8. What do you get? Can I see answers in the chat, please? 0.89. So the answer becomes 0.89. And if you look at the answers, it says it is 0. Anyway, the answer was always going to be D because all the other ones are incorrect. Now we'll quickly go through this. So I want you to use rules. Don't use reasoning, common sense, because they can trap you if you try to do that. Use the rules of physics. Don't forget, students, use the rules. An athlete runs 300 meters up a hill in 100 seconds. Okay. So this is distance, S. This is time, T. She then runs the same hill, runs down the same hill in 50 seconds. This is T. And S also is also 300 meters. She's going down, but it's still 300 meters. It's the same hill. What is her average speed? Well, average speed only has one formula. Average speed is equal to total distance divided by the total time. This should be known from now and forever. Average speed always have only one formula. Total distance over total time. As long as they ask you for average speed, from now on, you know what to do. So what is the total distance this person has traveled? The person has gone 300 meters up and 300 meters down. So the total distance is 600 meters divided by what's the total time? 100 plus 50, that's 150 seconds. Can you tell me what you get? What is 600 divided by 150? You must get 4.0 meters per second. That is part B, and that becomes your solution. How did you get the solution? You remembered the formula for average speed. That's the formula for average speed. Put it down, everybody. Make sure you have it. We move on to the next question. The diagram shows all these are from chapter 1. We haven't talked about heat yet. We haven't talked about heat, so we are not yet in thermal physics. Nothing to do with heat yet. We keep going until we meet heat. Then we know we are done with unit 1. So all these are from unit 1. We got to get 100 from them. We got to get 100. Now they said, what is the acceleration of the car? So everybody should know the two calculations that you do on a speed time graph. On a speed, this graph is called speed versus time. You should know that the area under the graph is distance. The area under the graph is distance. And the gradient is acceleration. So acceleration is the gradient. So all we have to do is find the gradient, which everybody should be able to find the gradient. Gradient is change in y over change in x, which means y2 minus y1 divided by x2 minus x1. So you need to choose which is your point number 1 and which one becomes your point number 2. For point number 2, you go down, the x here will be x2 because it's for point number 2. The y is y2 because it's for point number 2. For point number 1, the x is x1 because it's for point 1. And the y is y1 for point 1. Wow, you can now just come and put the values in here. What is y2? It's 12 minus. What is y1? It's 4 divided by. What is x2 is 2 minus. What is x1? 0. This becomes 8 over 2, which is 4.0. That becomes your acceleration, the gradient. Don't forget, acceleration is the gradient. But then when you get the area under the graph, which in this case you'd be getting area of a trapezium. Look at the shape. It's a trapezium. The two parallel sides are here, which means these are your A and your B. So yeah. Now, what is a weight? The questions keep coming. What is a weight? Weight is a force. What is weight? Weight is a force. That's why it's measured in newtons. It's actually calculated as weight is equal to mass times gravity. So here we are doing very little calculations. Most of the things are about theory. It's a lot of theory here. Here it says, what is weight? Weight is the force, because you can see it's mass times gravity, and its units are newtons. Weight is a force, and weight is the force of gravity. The force of gravity is called weight. So you can see it is part C. We move on. What is the relationship between the force on an object and its mass? What is the relationship between the force on an object and its mass? That is the same thing we've said. We've just been talking about weight. Okay. So the relationship between a force and its mass. This is Newton's second law. Force is mass times acceleration. Force is mass, resultant force. This is mass times acceleration. That's the only formula that has acceleration, mass, and resultant force. Now, can we find this one? Where the F is the subject of the formula? In A, no. F is not the subject. In B, no. In C, no. In D, no. So F is not the subject. Okay. What can we do? We can try to take A to the other side. We'll now have resultant force over A. This becomes the mass. So to get mass, you say resultant force divided by acceleration. Because it was multiplying on the right. When it goes to the left, it will divide. Do we have anything like that? Force over acceleration is mass? Yes. Part C. So this is Newton's second law that you must know. Now we keep moving. What statement about the... We're still in topic number one. What statement about the resultant force acting on a moving object must be correct? Resultant force. Okay. What statement is going to be correct? Let's see here. It is the change in momentum per unit time. Let's keep it there. It is the force needed. Let's just say you don't know. You do method of elimination, although I do know the answer. Ready? It is the force needed to keep the object moving at a constant speed. Well, this is wrong, because just from the second law, you see that whenever there is a resultant force, there is an acceleration. So if there is a resultant force, the speed won't be constant. It will be changing. So here, what statement about the resultant force can you make? It is the force needed to keep the object moving at constant speed? No. If the object is moving at constant speed, there is no resultant force, because resultant force automatically causes acceleration. Yeah. It is the impulse acting. No. Impulse is force times time. It's force times time, so it can be impulse. It's change in momentum. Then here, it is the largest force acting on an object. Resultant force is not the largest force. You get resultant force by adding forces. So the only answer that works is A. So it is the change in momentum per unit time. We say force is the rate of change in momentum, which is change in momentum divided by time, per unit time. Now here, a motor is used to lift different whatever. So this statement is a bit too long. Let me read the question itself. Which statement about efficiency is correct? Oh, which statement about efficiency? Okay. So can you see? When you are increasing the size of the load, okay, which means going horizontally, you're increasing the size of the load, it takes more time. So, which statement about efficiency is correct? Okay. The bigger the size, the more the time. So it's the same for everybody. Here, it decreases as the load increases. What statement can you make about efficiency? Well, efficiency, is it decreasing as the load increasing? No, because efficiency is the gradient. It's constant. Okay? Then, here it decreases. Efficiency, it increases. No, it doesn't increase. It doesn't decrease. It stays the same. That is why that graph is constant. It stays the same, yes. More information is needed, no. So this is going to be C. Are we together, everybody? Wait, let's see. It stays the same as the load increases. Ah. Time taken goes up as the load increases. The higher the load, the more the time. The higher the load, the more the time. So here, can I know? The higher the load, the more the time. The higher the load, the more the time it takes. So now the question was again, what can you say about efficiency? Okay, let me not run to say it is constant. Is correct. It stays the same as the load increases. It can change at some point because the graph is not complete. So let's just say more information is needed. I'll put this as more information, not C. An object is at depth h. Okay, this is still chapter 1. What is the total pressure at depth h? Pressure is equal to pressure P is equal to rho slanted P times G times H. This is pressure in a liquid. In any fluid, pressure is gotten by saying rho GH. So can everybody write this? This is pressure in a fluid. This is density. This is good. Here, this is the height. So this is rho GH. Pressure is rho GH. Okay. Here you can see rho, you can see G, you can see H. That's the total pressure, so it's D. It's D. Rho GH. H rho G. It's the same thing. They are multiplying each other. So don't forget that, students. Do not let me down. Pressure in a fluid, this becomes the formula. Of course, we will summarize all the formulas for chapter 1 for everybody who may need them. Why does the air leave the tire? This becomes question number 10, which says, why does the air leave the tire? So, a car tire runs over a nail and it makes a hole in it. Okay. The air in the tire leaks out. Okay. So, why does the air leave the tire? Well, something to do with pressure. Something to do with pressure is the one that forces it out. The pressure inside is greater than the pressure outside. This is 100% correct. So your answer is part A. The pressure inside is more than the pressure outside. So yes. Now we go to question number 11. Still from topic 1. Which graph shows the relationship between pressure and volume? Right. Here, for a fixed mass of gas at constant temperature. So here we want to say, this is a chapter on ideal gas laws. This is a chapter on ideal gas laws. Give me a second to take this call. Okay. So what I want people to know is that, let me mute the mic for 1 second. I need to. they were asking, what is the relationship between what is the relationship between pressure and volume for for fixed mass so you basically the important things, and you're going to see this relationship, it keeps coming for those who want to go continue students and do engineering and whatever. Pressure, volume, and temperature, it keeps coming, and you're going to learn about it in thermodynamics. Now what you must know is that we take two at a time. We don't look at all three together. So it's like we take two, then we look at two more, then we look at two more, stuff like that. Okay? So if we want to take the relationship between pressure and volume, make sure you don't change temperature. You just change pressure and you see what happens to the volume. Or you change the volume, you see what happens to the pressure. Now, this is not rocket science. Everyone in here knows that the relationship between pressure and volume is when you reduce the volume, the pressure goes up. So pressure is inversely proportional to the volume. When you increase the pressure, the volume goes up. When you reduce the volume, rather, the pressure goes up because the particles have less space and they're bumping into each other more. So the lower the volume, the higher the pressure. So they have an inverse relationship, which means when one goes up, the other goes down. This is not an inverse relationship because you can see that as the pressure goes up, the volume is also going up. So this is wrong. What about part B? Part B, you can see that as the volume goes up, the pressure comes down. Now, the biggest question we will now have is, as the volume goes up, the pressure comes down, but is it a straight line relationship or is it a curve? Well, I will not answer that, but I'll teach you another way that you can do, then I'll answer it. Another way that you can do this is, I won't answer that question, okay? But this is potentially correct. As the volume goes up, the pressure comes down. Right? That's true. When you make something very big, the particles have more space. There's less pressure. What about part C? Part C is saying the pressure goes up as the volume goes up. But that's a lie because this is not volume. This is 1 over volume. So it says listen to this. Everybody, watch this. What is going on here? 1 over V, it means what? It means whatever is happening here, take it vice versa. So, if I look at this graph, it's going towards the right, which seems to tell me that volume is increasing. But because this is the flip of it, it means volume is actually decreasing. So this is saying volume is decreasing as you move to the right, because this is 1 over volume. So the volume is decreasing, but you can see that the pressure is increasing. So this is another one. This is another good one. They are inversely proportional to each other. But if you see now part D, let's look at part D here. Look at part D. It says that as the volume decreases, so can we all agree that this is easy. Can we agree that when we see 1 over volume, it means it's actually decreasing? So here the volume is decreasing and the pressure seems to also decrease. Here the volume is decreasing and the pressure also seems to decrease. So now, which one becomes the correct one? Which one becomes the correct one? Well, here pressure was related to volume, but you can see that as the volume was increasing, the pressure was decreasing. The problem we have, though, is that this relationship does not tell us what happens at 0, 0. It doesn't tell us what happens. This one is the best because they are inversely proportional to each other, One is decreasing as the other one is increasing, but the good thing is they are both zero together. So that is what makes this one then be correct. Okay, I'll answer the messages a bit later. So we'll continue. This becomes the solution. So the solution is C. C is the solution, and that's the answer. Are we together, everybody? The answer is C. Right. Let's go to this next one. So the what made this correct was the 0, 0. When there is no volume, there can never be pressure. So don't let me down. When there is no volume, there can never be pressure. Anyway, I think we are wrapping it up. It's time for us to look at chemistry a bit. But I'm going to do this as the last question. And then I'm going to continue on with this. The graph shows the internal energy, right? How it changes with temperature. Okay. So the internal energy increases as temperature increases. No problem. Now, here, the question becomes, what is the increase? The question now says, what is the increase? Sorry, I needed to respond. What is the increase in internal energy of a block of the same mass when its temperature rises from 40 to 80? So, listen, everybody. They want increase in internal energy. So, they want, if we can say it, it's delta internal energy, the change in internal energy. Okay. Same metal, right? Same metal. So, what was the mass of this one? This was mass 1 kg. Now, we are studying a different mass. Here we are studying the same metal, but now it is mass 0.125 kgs. So now what we want to see is how much does internal energy change if you change the mass? The metal is the same, but you are changing the mass from 1 kg to 0.125 kg. Let's see something. For the 1 kg, when we changed the temperature from 40 to 80 degrees, here, from 40 to 80 degrees, the internal energy changed from, this is 812, it went all the way to 824. So it went to 824. The internal energy changed from 812 to 824. This is for 1 kg. The change was 12 kilojoules from 812 to 824. Now they are saying it's now for a block of the same metal, but the mass is no longer 1 kg. It's now 0.125 kgs. What will be the increase in its internal energy if the mass rises by the same amount? Did you understand, students? A block of 1 kg, the internal energy changed by 12 kilojoules. Now, we have a block of 0.125 kgs of the same amount, of the same metal. How much does the internal energy change? Ano, mute the mic. Ano? Mute the mic. Now, there is a relationship that you must know. And the relationship is this. Change in energy is proportional to the mass. Okay? change in energy is going to be proportional to the mass. So what will be happening is, if I change the mass by a certain amount, I will change the energy by the same amount, but it's like a multiplier. So I would say for me that what did we do? Let's put it like a proportion. Put it like a proportion. 1 kg gives you 12 kilojoules. 0.125, was it 0.125? 0.125 kgs gives you X. We don't know. Okay? It gives you X. We don't know. Now, what you do is when you have proportion like this, you then cross multiply. So you'll be saying 1 times X will be equal to 12 times 0.125. Then you just get X. 1 times X is just X is equal to, what is 12 times 0.125? 12, somebody quickly punch for me. 12 times 0.125 is 1.5. So this is 1.5 kilojoules. Well done. 1.5 kilojoules, which is here 1,500 joules. So this becomes C. So what you must know is that when you change, the energy changes as you change the mass. As you change the mass, energy changes. This is only going to be true for the same metal. So it has to be the same metal. They will tell you that it is the same metal. And now you must know that for the same material that you have, then you're going to have a temperature change that is related to the mass change. All right. So the factor is the same. Anyway, we'll continue with this unit 2. This was the very first question from unit 2, which is about energy. This is the very first question. Okay. So you've seen something about internal energy. We will meet and continue with this physics. Now we have to do a bit more of chemistry. I hope you understood. We'll keep working. We're going to continue with our paper.